Okay. So the answer of this differential equation is composed of two parts, which are yc and yp. We are going to find yc first by setting the equation to be a homogeneous differential equation, and then write down the characteristic equation, which is m squared plus 2 minus 2m plus 1 equal to 0. So with this equation, we should be able to find two roots of m, which are 1 and 1. Okay, 1 and 1 is kind of repeated real root, which is in the second case of our homogeneous differential equation. Now, yc is equal to, it's a repeated root which has case equal to 2. Okay, c1. Right? Okay. Now, let me write down this way. Okay, so if you take a look at the function in yc, you have exponential of x and x times exponential of x. Okay? Now, yp. Yp, we got to find the set, use the set of the function on the right hand side of the equation. We have how many functions on the right hand side? Two functions, right? We have f1x equal to x times exponential of x, and f2 is equal to exponential of x. We will find the set of the UC set, right? Because you have two functions. Take a look at the first one first. The first one, you do the first derivative, you would get what? Right? And the second derivative of it is equal to right? And the second function, the first derivative of the second function is exponential of x. If you still keep doing the derivative of exponential of x, you still getting the same function. So I would say that we are going to end up with this. Okay. So for the first function, we would get UC set of the first function is equal to this, and the UC set of the second function is next. You do union thing. Okay, you do S1 union to S2 equal to, this is going to be the overall UC set of both two functions f1x and f2x. And this one, if the function inside this UC set as this one is not repeated or is not the same as the function in yc, then you can assume yc as the summation of this function. But in this case, if you take a look at it, is this the same? Is this repeated as a yc? It is, right? So you just cannot write it as the summation right away. You got to times the function inside the x set with x. Okay, time with x. the new x, the new function inside our UC set is. And then we got to take a look at it again, whether the function inside the new set still repeated or still be the same as the function inside yc. If it is still the same, times the function inside s with x again. You got to repeat time with x until there is no any function in here repeated with the function in yc. Okay, so we time with x again. We got our new s is equal to x to the power 3 times exponential of x. And the second function is x to the power 4 or x squared times exponential of x. Now, any function in here repeated with any function in yc? No. If no, then that is it. So you can assume that your yp is equal to the summation of these two functions. And then the next step is just repeated as our first example, that we just swap our yp back into our differential equation. Okay. Now, we are going to plug yp back into our differential equation, but our differential equation has the second derivative of y in there, so we got to do derivative of this yp. Okay. The first derivative of this yp is equal to this, right? I don't want to do differential of this term in. I need to write down in order to make it clear that why there's such a this term after we do differential of it. Okay, so we would get like this. I just arrange this term again because I see x squared and times exponential of x for both term here. Just want to put them together. That makes us do the next derivative easier. That is our first derivative term. Now we do second derivative of that yp. We would get which is equal to again, just rearrange the terms which has the same function together. This one you have x squared times exponential of x, which is the same as this one. So this one we got 3a1. We have 3a1 here. So you combine them together, you would get 6a1 plus a2, right? And then here you have x times exponential of x. Here you have x times exponential of x. With this one you have 2a2, this one you have 2a2. So we would get 2a2 do we have a1? Oh, we have a1 here and 6a1. This is 2a2. So we got 6a1 plus 4a2 x times exponential of x. And then the last term is 2a2 times exponential of x. After we get this, we put yp, the first derivative of yp and the second derivative of yp into the differential equation. So we would get a1 x to the power 3 exponential of x plus 6a1 plus a2 x squared exponential of x plus 6a1 plus 4a2 x times exponential of x plus 2 a2 exponential of x. That is the first term minus 2 times the first derivative, which is a1 minus 4, and then plus y, which is equal to quite long, but it's not. Now, you have a1 x to the power 3 times exponential of x here, and the same term here. You plus them, you would get 2a1 x to the power 3 times exponential of x. But this term you have minus 2a1. So this term cancelled out. Okay, terms x to the power 3 times exponential of x all cancel out. And next, if you look at the term of x squared times exponential of x, take a look at the coefficient a1. You get 6a1 here and minus 6a1 here cancel out. This term cancel out. This one a2, this one a2, you got 2a2, this one minus 2a2 cancel out. We have 6a1 here, 6a1 times x times exponential of x. We have only one term here. It just cannot cancel out with any term. We just write it down. We have 4a2x times exponential of x here. We have minus 4a2x times exponential of x here. So this term and this term cancel out. Now you have this one left, which is 2a2 exponential of x equal to x times exponential of x plus 4 exponential of x. It's a long equation, but lots of terms are cancelled out. So you left only two terms at the end. And next, since you have only two terms left, we are going to compare the coefficient of both sides. Right now we have the first function is x times exponential of x on the right hand side and on the left hand side, and the other function is exponential of x. Now we take a look at the first function, which is x times exponential of x. If we want this equation correct, we would get 6a1 equal to 1. So a1 is equal to 1 over 6. The second function is the exponential of x. So we got 2a2 equal to 4. So a2 is equal to 2. Now we know our yp is equal to 1 over 6 times x to the power 3 times exponential of x, and plus 2x squared times exponential of x. Now, our y is equal to yc plus yp. Our yc just forgot c1 plus c2x times exponential of x, right? And then plus yp, which is 1 over 6 times x to the power 3 times exponential of x plus 2x squared times exponential of x.